Okay, I'm going to show you how to draw Lewis dot structures for covalent molecules. So I'm going to go through a couple of examples. I'm going to go through water. I'm going to go through CH4, and I'm going to go through carbon dioxide. Okay, so when we draw Lewis dot structures for molecules, we're going to go through a couple of steps. The first thing that we always have to do is we have to make sure that we count the valence electrons in our molecule, because that's going to let us know how many electrons we have to work with. So when I look at water, I'm going to use my periodic table to figure out how many valence electrons each atom has. Now, the whole goal of drawing these Lewis structures is to make sure that every atom has access to 8 electrons, like noble gases, so that they have a stable configuration. Hydrogen will only need access to 2 electrons because its nearest noble gas is helium. So that's our ultimate goal here. So the first thing that we're going to do is count our valence electrons. So hydrogen has 1 because it's in group 1. And there are 2 hydrogens. Oxygen is in group 16, so it has 6. So I have 8 total valence electrons. Okay, now my next step is to determine what atom goes in the center. Now, there are rules for this. Hydrogen can never go in the center. Carbon pretty much always goes in the center. And when you're not sure, it's the least electronegative atom. However, I'm going to go ahead and tell you that typically the ones we're going to draw in this class, the one that goes in the center is the one that I only have 1 of, okay? That almost always works. All right, so here oxygen's going to go in the center. So I'm going to put my hydrogen atoms on either side. Now, I know that if these atoms are bonded together, they have to share at least 2 electrons, okay? Because 2 electrons is a single bond. So I'm going to start by connecting these with single bonds. That's one way to draw it. Another equally acceptable way is to actually show those electrons as dots, okay? All right, so I've started out by connecting my oxygen to both of my hydrogen atoms with single bonds. Now, because each line is 2 electrons, I've used a total of 4 electrons so far, and I have 8 to work with. So, what am I going to do with the remaining 4? Well, normally we would say let's satisfy the outside atoms first, okay? But hydrogen is already satisfied because hydrogen only needs to have access to 2 electrons, and it has those in the bond. So the outer atoms are satisfied. So with those remaining 4 electrons, I'm going to add lone pairs to the oxygen atoms. Okay, and I'll show that here as well. There's just 2 different ways of drawing the same structure. So now I have to check my structure and see if it works out. All right, so first I want to make sure that I used exactly 8 valence electrons, no more, no less. 2, 4, 6, 8. All right, so that's good. Now I need to make sure that every atom has access to 8 electrons, except hydrogen, which only needs 2. Another exception you should know is that boron only needs 6. But boron and hydrogen are the only 2 exceptions you need to know. Okay? All right, so let's check. This hydrogen has access to 2 electrons. This oxygen has access to 2, 4, 6, 8 electrons. And this hydrogen has access to 2 electrons. Okay? So this structure meets all of our requirements, so it's good. Okay? Remember that these shared electrons are being accessed by both of these atoms. All right, so let's take a look at CH4 next. Okay? Again, the first thing that we want to do is that we're going to count our valence electrons. Okay? So carbon has 4. Each hydrogen has 1, and there's 4 of them, for a total, again, of 8 valence electrons. It's not always going to be 8, it's just coincidence that it happened twice in a row. All right, so what atom's going to go in the center? Well, I know it can't be hydrogen, so I'm going to put carbon in the center. And I'll put my hydrogens around it on either side. Okay, now I'm going to start by connecting these with single bonds. So again, you can show it like that with lines, or if you prefer, you can show it with dots. Both are equally correct and acceptable. All right, now let's see how many electrons I've used. I've used 2, 4, 6, 8 electrons, And that's how many I had. So my structure's probably done, but let's double check. All right, each hydrogen needs to have access to 2 electrons, and they all do. And carbon needs to have access to 8. 2, 4, 6, 8. So this structure is correct. I'm going to show you one more structure that is going to be a little bit different than the first two. So when we look at the structure of carbon dioxide, we're going to start the exact same way. We're going to count up our valence electrons. Carbon has 4, and each oxygen has 6. All right, so carbon's going to go in the center, and I'm going to put the oxygens on either side. Now I'm going to start by connecting these with single bonds, just like I've been doing. So I've used 4 of my electrons. Oops, should have added those up. This comes to a total of 16 valence electrons. All right, so I've used 4 of my electrons, which means I have 12 remaining. So I'm going to satisfy the outer atoms first and then go to the central atom. All right, so I've used 2, 4. And again, you can show it like this if you prefer. All right, 2, 4, 5, 6, 7, 8, 9, 10. Okay, that oxygen's now satisfied because it has 8. 11, 12, 13, 14, 15, 16. That oxygen's also satisfied because it has 8. Now, here's the problem though. I've used all 16 of my electrons. But is carbon satisfied? It's not, because carbon only has access to 4 electrons right now. All right, so let's explore a couple possible solutions. So I could take some of the lone pairs on oxygen and give them to carbon. But that creates a new problem, right? Because now these oxygens aren't satisfied. So when you have a situation where you don't have enough electrons to satisfy everything, that's your clue that you need to take some of those electrons and make double or triple bonds. So those electrons that used to be on the oxygens, I've made them shared pairs of electrons. Okay, so now we have 2, 4, 6, 8, 10, 12, 14, 16 electrons. Okay, so that's good. And we see that each atom has access to 8. Oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. And I can show the same thing down here. They're sharing 4 electrons. Okay, this is something you're going to practice a lot, and just ask me if you need extra help and we can go over more examples.